Here will be a few examples that look at using the different forms of a quadratic function to actually find the equation for the function. So we have standard form, which is just an ax squared plus bx plus c. That's just called your standard form of a quadratic. You have a squared term, the coefficient of a, an x term, or a single power of one term. Coefficient is b, c is just a constant. Then you have this vertex form, which you're actually given the vertex, either a low or a high point on the graph, but the vertex is hk. Notice the h has the opposite sign, and the k will keep the actual sign of the point. And lastly, we have this factored form, which takes the zeros or the solutions to equal 0 or the x-intercepts of the quadratic function and sets them with opposite values back into these factored products of, for example, x plus 3, x minus 8, x plus a half. It puts the zeros back into factored form with a quantity that has an opposite sign. All right, so this first example is going to look for an equation of a quadratic or a parabola. It gives us the vertex and it gives us a point that it passes through. So if you're given the vertex and you need an equation, then you're going to want to use vertex form. So for vertex form, it's an a value times x minus h squared plus k, and the vertex is this hk value up here, the 7, 3. So if I replace that, then it'll be a times x minus 7 squared plus 3. Again, if the point is 7, 3, you change the sign inside and you keep the k value outside. So now all we need is an a value. We don't have that, and you can't just guess it. So we're actually going to find it, and we're going to plug in the point that we were given, that extra point, that 3, 7. 3 is the x value, 7 is the y value, so you'll just plug 3 in for the x, you'll plug 7 in for the y, you get 7 equals a times 3 minus 7 squared plus 3. Order of operations, you'll subtract over the 3. 3 minus 7 is negative 4, but you end up squaring that, so you get positive 16. And then when you divide both sides by 16, you get 4 over 16, but that reduces to 1/4. So 1/4 is your a value. So your answer, because you have to give the equation, will be positive 1/4 times x minus 7 squared plus 3. And that's in vertex form. If you want it in standard form, you'll have to FOIL out that quantity, multiply by 1/4, and then add 3. But you're welcome to leave in vertex form for this problem. Unless it asks you for a specific form, you can just leave it. Another example here looks at finding an equation for a quadratic with a vertex of 15, 3, but now it gives you the y-intercept. So again, if you're given the vertex, you want to use the vertex form, a times x minus h squared plus k. The 15 is your h value, the 3 is your k value. So when we plug those in, we get x minus 15 squared plus 3. And since we need to find the a value, we'll plug in the fact that we have a y-intercept of negative 15. And what that translates into, y-intercept is where it crosses the y-axis, so it's the point 0, negative 15. So we'll plug 0 in for x, negative 15 in for y, for our y and our x in our vertex form, and then we'll find our a coefficient. So we get negative 15 equals a times 0 minus 15 squared plus 3. Again, following order of operations, we'll subtract over the 3. 0 minus 15 is negative 15, but 15 squared is positive 225. And then when you divide both sides by 225, I don't know that reduces. If I do 18 over 225, yeah, I get negative 2 over 25 is my a value. Again, you need to simplify if you can. Don't give a decimal. So our final equation, because we found our a value, that was what we were trying to look for. the negative 2 over 25. We found that guy. So our final answer is y equals negative 2 over 25 times x minus 15 quantity squared plus 3. Vertex form with the given vertex that passes with a y-intercept of negative 15. And that is a negative there. I don't know that you can see that too good. Negative. Okay. Here's another one. Vertex is given. It gives you another point. Same thing. Use it. If it gives you the vertex, do the vertex form. At this point, if you wanted to plug in everything, you could. You have a vertex HK, you have a point XY, so I can plug 4 in for Y, 3 in for X, 0 in for H. I need to do a minus 2 for the K, and then I get 4 equals A times 3 squared minus 2. I'll add over the 2. Get A times 9. I'll divide the 9, which reduces to 2/3. Divide both of those by 3. So your equation for your answer is a positive 2/3 times x. So it's minus 0 because the h value of the vertex was 0. But you can actually write that as 2/3 x squared minus 2. The minus 0 is not necessary to give for the final answer. Just as if the end had been a plus or minus 0, you would not have to write it at the end. So that's your final answer. Okay. Here's an example that gives a picture, but at the same time does the same exact thing. This 2 up here is the vertex. It's not just a random point. It's actually a vertex at 2, 0. And the other one is a y-intercept, the other defined point, but the point itself is 0, negative 4. So again, we have a vertex HK, another point XY. So if we use our vertex form, A times x minus h squared plus k, we have A times x minus 2 plus 0, so you don't really even have to write the 0 at the end. And then we can plug in our x and our y values. Y is negative 4, x is 0, minus 2 squared. So we get A times negative 2, which is positive 4. And when I divide both sides by 4, I get my A value is negative 1. So to plug that back in to our formula, I'll write the negative 1, but you don't really have to write the 1. X minus 2 squared, if you remember, it was plus 0. So really, that would clean up a little better to just be negative times x minus 2 squared, and that would be the final answer. You don't have to write the 1, but you do need the negative, and you don't have to write the plus 0 at the end. All right. So for this next one, slightly different because now it's giving you zeros and a point that it passes through. It's not giving you a vertex. So if it gives you these zeros, again, these are x-intercepts. If you had a graph, it would be where they actually crossed the x-axis. So if it gives you zeros, you actually want to use the factored form, not the vertex form. Use the vertex form if you have the vertex or need the vertex. But if we use factored form, it's only quadratic, so it's only going to have 2 factors. At most, it would have 2 solutions. So the fact that I have a factor at negative 1 gives me an x plus 1 as a factor. And my 0 of 5 gives me an x minus 5 as a factor. Again, you switch the sign when you put them into the factors. And now we just need to find our A value. Again, you can't just guess it. We'll take and use the fact that we have this given point that it passes through. Negative 2 is our x value, 6 is our y value. And so we'll plug in for the y's, and there's 2 x's here. So we'll say 6 equals A times negative 2 plus 1 times negative 2 minus 5. You'll actually plug in negative 2 on both of the x's. Since there are 2 of them, they're the same value, so they need to be the same number from your point. And then we'll clean this up and find A. So we got A times negative 1 times negative 7. So that's positive 7. A ends up being 6 over 7. So that is going to go back up and be our A value on our factored form. So our final equation is 6 over 7 times x plus 1 times x minus 5. And you can leave it in factored form, or if you want to FOIL it out and then distribute the 6 over 7, you can, but you'll just have fractions. But that's your answer. Okay. Here's another one. Find a quadratic with the given zeros of negative 6 and 2, but now it has a y-intercept of 5. So again, we're given the zeros, so I'm going to use the factored form, which is y times a, or y equals a times x minus r times the quantity x minus s. And again, the r and the s are your zero values. So a 0 of negative 6 is going to be an x plus 6 because it's minus a negative. And a 0 of 2 is going to be x minus 2 as a factor. Need to find our a value. So we'll take what we have and we'll use the fact that it has a y-intercept at 5, which again translates into the coordinate point 0, 5. So we'll use 0 for our x value, 5 for our y value, and we'll just plug those in for the y's and the x's in our factored form. So we get 5 equals a times 0 plus 6 times 0 minus 2, and that gives you 5 equals a times a 6 and a negative 2 multiplied, which is going to give you a negative 12. So you end up with an a value of negative 5/12. Again, don't use a decimal, use the exact fraction simplified. And 5 over 12 is simplified. So our formula is negative 5/12 times x plus 6 times x minus 2. And again, you can leave it or you can FOIL it out, but if it's accepted factored, just leave it factored. And you can graph it if you want to verify that it does have those zeros and that y-intercept. You know, you always have that option to graph to verify that your equation matches the setup that you've been given. So if it gives you vertex, use vertex form. If it gives you zeros, use factored form.